Areas of composite figures. Composite figures can be defined as a figure made of two or more 2D figures of which the area formulas are known. They will need to be decomposed or broken down. So let's look at an example. Use my handy dandy ruler, straight edge. So I'm giving a figure that has a side of 10 feet, a base of 12 feet, this is 4 feet. From here to here is 8 feet. And so we can find some different ways of breaking this down into parts. I could break it down like that and have a trapezoid and a rectangle, or I can make a nice long rectangle and a triangle. And I think I'll do it this way for this problem. So I'm going to draw a dotted line to show my two different shapes and label them. So I have one for the triangle and two for the rectangle. So I want to find the area of each of those. So triangle, and 2 is the rectangle. And we have the areas of those. Area is equal to 1/2 base times height, and area is equal to base times height. So the rectangle is pretty easy. We have a base of 12 and a height of 4. If we go all the way across, it's 12 and down 4. And so my area is equal to the base 12 times 4. And so the rectangle has an area of 48 feet squared. So what's the area of the triangle? This may be a little tougher to see, but remember the height has to be intersecting at a right angle with the base. So we could treat this as the base or that as the base and the other one as a height. Well, if this length is 4 from the other side and the whole thing is 10, then this piece is 6, even though this is not drawn to scale. So 1/2, I could treat that as the height, 6, and then the base, or the base, it doesn't matter. The base, if the whole thing is 12, and this is 8, then this is 4. 4 plus 8 is 12 for the whole piece. So simplifying that whole thing gives me 1/2 of 6 is 3. 3 times 4 is 12 feet squared. And if I add those two together, I get a total of 60 feet squared. Sometimes we will need to find the area with overlapping figures. So for example, I'm going to draw a diagram here. So I have a diagram that has this side of a square as 12 feet and this side as 12 feet. But this is not quite a square. This is going to be 15 feet and 12 feet. And then they give you this dimension right here. From here to here is 8 feet. And from here to there, the vertical height is 6 feet. So what would the area be total? If we take the area of this one, then we've already included this square. So if we take the area of this one, we're going to have to subtract that area. So we need to find that in order to find the total area. So I have a total of 1, 2, and then 3 pieces. So area number 1 is easy enough. It's a square. Area equals length times width. So area is equal to 12 times 12. And area is equal to 144 feet squared. Area of 2, area is equal to length times width. Area is equal to 15 times 12. And then the area is equal to 1 280 feet squared. So the third part is the part that I have to subtract. And if I have a total of 15 here and 8 here, then that means that this piece is 7. So the area of this little square is length times width. Area is equal to 7 times the width would be this length. Well, I know the total length of 12. Actually, over here I have the total length of 12 because right here is 6. So that means this piece is 6. So I'm going to multiply, and that gives me an area of 42 feet squared. And now I can add these two, subtract out that one, and I get a total of 282 feet squared for the area of this figure without the overlapping piece.